tell me, can anybody tell me that what a significant figure is? Any idea about that? This is your book page. I'm gonna share which page I'm going to, or I'm at that right now. This is your book. If it is visible to you, this is basically your page number 3. Okay, so don't worry that in 3 lessons we have just gone through 3 pages. No, there are so many things which are basically required to be having a good base before starting with a good base in physics. That's why I tried my best to make your basis strong, and then I would continue with the formal study of the book. Is it? So, yeah, my question was, what are the significant figures? What does it mean by significant? Can anybody tell me, please? Yes.
Sir,
Anyone?
sir,
Yeah. Yes. Sure.
sir, significant means that something important or like worthy.
Important. Very good. Important. Something important is called your significant. So when you are going to take some measurements, you have some importance related to your, figures or digits or data what you are going to collect. So how many numbers of digits are important for you in your data? Let's say I'm going to take a value of 9.81 meter per second square. Then I'm going to take 9.8 meter per second square. And there is another student who is going to write 10 meter per second square. These all are the values of, gravitational acceleration or the acceleration of free fall. In your syllabus, we use 10. Later on, we will use 9.8. Then we use 9.81. So all of them are same things. But how many digits are important for me? This is called your number of significant figures. So in any data, the important number of figures which can represent that data with accuracy, that is called your significant figure. So here I can write a proper definition for that. It would help you out till your A levels, that all accurately known and first doubtful digit is called significant figure. Okay, significant figure. How? For example, if I say that here in 9.81, this is accurately known, this is accurately known, this is my first doubtful digit. Here I got doubt because in data maybe the values were going to be repeated. Then I will call it first doubtful digit. Then here the number of significant figures are 3. But here I have, this is accurately known, and then I got doubt over here. So here I have number of significant figures 2. And here I have this 1 accurately known, and this 0 can be a doubtful for me. Then significant figure would be equal to 1. Later on I will tell you that 1, 10, 100 are all these values. They can be having variable significant figures depending upon the instrument. But here you will be able to know that here number of significant figures are 1. Now when we talk about that, the every measurement in the quantity is attempted to find the true value in a subject for to the errors arising from the limitation of the operators and experiment. The number of significant figures, I mean number of figures, are called significant figures given by the measurement indicated how accurately we think, and more figures should not be given that then are justified. For example, it is basically written in a complicated way, but I have simplified this all in my notes as well, that all accurately known digits in an experiment and first doubtful digit is called your significant figure, right? I'm gonna shift the window. For example, when I say that I was having an experiment 5.436, then I was having the values 5.437, then I have 5.435, then I have 5.434, that stuff. What does it mean? It means that I have some values which are accurately known in all cases. Is it clear to all? This one,
Yes,
this
sir.
one, and this one. There are 3 accurately known digits in all the readings. 3 accurately known. Okay. And what about the first one? This fourth one, this is doubtful because I have variation in the 4th digit. So in this setup, my accurately known digits are 3, and then 4th one is the first doubtful digit. This is my first doubtful digit. Okay, are you getting it? So here in all that, my number of significant figures are, what are the significant figures? They are 1, 2, 3, 4 over here, 1, 2, 3, 4 over here, then 4, and in all that stuff, I have 4 number of significant figures. Is this clear to you?
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
great. So the problem with us will be, we are allowed to have 2 to 3 significant figures in our answers. Okay, not more than 3. 2 to 3 significant figures are allowed in our syllabus. Okay. For example, I have data which is, let's say, 5,420. How many significant figures do I have here? Here there are 4 significant figures, but I have to round it off to 2 significant figures or 3. So this is called to round off nearest hundreds. Okay, are you getting it? Rounding off to nearest hundreds. So when I'm going to round it off to nearest hundreds, this would become 5000. Sorry, it is nearest 1000 because it is 5400. So this value is basically rounded off or rounded down, you can say. Then here, if you think that, yeah, my answer is basically 5000, but my actual answer is 5420, so don't worry about that, because this is what this is, it into one significant figure. This answer has been rounded off to one significant figure. So when I will call, or I will go through the rules of significant figures mentioned in your book, I will be basically having this example. For example, a value of 4.5 for the measurement has 2 significant figures, but 0.385 has 3 significant figures. 3 being the most significant and 5 being the least significant. Is this very clear to you? So the leftmost digit, which is your leftmost digit, this one, that is basically 0. So when it is 0, it is not significant. It is just a space occupier. Then this is your least significant, most significant. For example, if I tell you it is 0.385, so this 0 has no value at all. Okay. So this 3 is most significant and this 5 is least significant. And if you remember, that digit which is at the 1000th place, definitely it has more significance, and the value which has which is at units place, it has less significance. That's why it is very easy and non-confusing rule for you. Don't get confused in that. That is, it is one where are the least sure about, since it is, it might be it might be 4 or might be 6. So we are basically not sure about this one, this 5-1, right? This was the first doubtful I told you. Is this clear? This was the first doubtful. So perhaps it had to be estimated by an experiment because the reading was between 2 marks on the scale. So this all refers this statement that here 0.038 they are accurately known, but 5 can be doubtful because maybe it was 4 or maybe it was 6, but we have rounded it up or rounded it down to 5. So this was first doubtful. So here I have these 3 number of significant figures. Then is this clear to all? This first slide?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, great. Then I have significant figures. When doing calculations of the answers, you should have the same number of significant figures as the measurement used in calculation. This is very important thing. I would figure it out and will make it as clear as possible for you. This statement, that in your answer, what would be the count of significant figures, right? The number of significant figures, as I told you, that they must not be greater than 3. I mean, it is obviously said that they should be in between 2 and 3. But here the rule is, in your data, number of significant figures of answer must be same as the least number of significant figure of data. I will explain it to you, don't worry. But here, this is a sort of rule. Is there anyone who is going to raise hands? No. I got some notification sound. If you have any problem, you can ask me directly, no problem. So I told you that how many number of significant figures are appreciated in the answer. That must be equal to the least number of significant figures in your data. For example, here, if you have calculated the answer to 3.418485062, this would be written as 3.4 if the measurement had 2 significant figures. If the data is having the information what you have collected from your measurements, if it has the 2 significant figures, then your answer should be 3.4. And if it is it would be written as 3.42 if there are 3 significant figures in your raw data. Note that the deciding the least significant figure, you look at the next figure to the right. If it is less than 5, oh, there is another thing which is mixed over here. Basically, if I call it, it is rounding up data, right? Here, while you are getting significant digits or significant figures, you have to consider the digit you are going to drop. For example, you are having 3.41856062. So when you are going to drop the digits, if you want 2 significant figures, this one, so you have to drop all the remaining ones. When 2 will be dropped, it will have no effect on 6. When 6 would be dropped, it will increase this 0 by 1 because 6 is greater than 5. Here it is mentioned, if it is greater than 5, it will increase the next left digit by 1. So here it would be 1, and if you are going to decrease round this of 1, it would become 5 because it have no effect on it. Then now 5 would be basically rounded off, then it would become 9, and when 9 will be rounded off, it will become 2. So if you want to drop this one, it has no effect. But if you want to write it down, 4.31856062, then I told you that rounding it off this, it will have no effect on this. 6 will make this as 1. Then when you are going to drop it, it would remain 5. Dropping this 5, it will be 8. Sorry, it would be 9, right? Dropping this 9, it would become 2. So I would have 3.42. How much? 3.42. So this is what in your book, 2 things are basically addressed together, that to get number of significant figures, we have to process the data, and the answer is written to the least number of significant figures in my data. And third thing, when we are going to get a significant digit, we have to round the data off. Okay, is this clear to all? I will give a recap to you, don't worry, recap without book stuff, in my own simplified way. So this was basically books stuff. So I worried that maybe I'm going to teach you right directly without the book. So if people will be getting confused while going to study the book. That's why I have basically included the book as a reference in my slides. Otherwise, I will explain this all without the book as well in my recap session, right? Is this clear to all?
Yes, sir.
Yes.
Okay.
Sure.
Now,
Yes, sir.
Well done, well done. Thank you. Now, significant figures, there is another rule for that. If the number is expressed in terms of standard notation, I mean, which is actually an exponent of 10, the number of significant figure is the number of digits before the power of 10. Whenever you are going to represent a number in terms of 10 power x, let's say, whatever that power is, 10 power something, then the number of significant figure are these digits before the multiple sign. For example, if I have 4.92 into 10 raised power 5, if I have 5.2 into 10 raised power 6, if I have 1.0 into 10 raised power 4, if I have 1 into 10 raised power 9, these all have different significant figures. Here, number of significant figures are 3 significants. Here, 2 significant figures. Here, 2 significant figures. Here, 1 significant figure. Right? So when you are going to write that number in terms of power of 10, the number of significant figures are basically all the digits before this multiple of 10, before this multiplicative sign. Is this clear to all?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Good. So let's have a explanation for that all. As I told you, that the significant figures are basically significant figures are all accurately noun. These are the notes, very important notes. I mean, a recap of the significant figures. Then you people are requested to, if you write it down, then it would help you out, or if you take a screenshot when I complete, then in both ways it would be very helpful. All accurately noun and first doubtful digit in any measurement is called significant figure. Okay, in any measurement is called significant figures. Got it? For example, if I have a data of 4.563, I have a data of 4.564, 4.569, and so on. In this, basically, I have 4.56 accurately noun, because this is available in all readings, and then the last one is my first doubtful digit, right? I will write in another way. Let's say this is okay. Come on, don't get hang up. Oh, sorry. Maybe it is getting lagging. So let me close this and then I would be back. One note. Okay. Meanwhile, we will be switching to the next tab. I mean, the other one in which we can write on another setup. This one. Yes. Here. Yeah, I was at this point that let's say I have some numbers 4.653, 4.654, 4.659, and so on. Let's say I'm going to add some more digits to that, to this one, right? Here, if you consider that 4.65 is accurately noun in all readings, it means these three are accurately noun digits. Is it? Now, the third one, this one, is the first set of doubtful digits. Here you have a doubt. This is second doubtful, so I cannot believe in this one. So I have significant figures over here, 3 plus 1, which is equals to 4. Is it clear to all?
Yes, sir.
Okay, so when we talk about this significant figures, so this must be very clear to you that these all accurately noun and first doubtful digit is my significant figure. Now let's talk about how to write significant digits or significant figures in answers. This is important thing, and that was addressed in the book. So in answer, your data will be having least significant figure in the data answer. For example, if I have distance is equals to 456 meter and your time is equals to 25 seconds, then what will be the speed calculated over there? Speed will be basically distance divided by time. So it would 456 divided by 25. If you have calculated, then please calculate it for me.
18.24.
How much? Sorry, can you repeat?
18.24.
Yeah, here it is 18.24. Now, very good. It's really important to know that here I have four significant figures. How many significant figures I have? Four significant figures. Now, I would not write the answer into four because what is the least number of significant figure in my data? Here I have three. Here I have two. So my answer should have two significant figures. How much significant figures should I have in my answer? Two, because I would follow the least significant figure in my answer as per the indicated in the data. So answer would be basically 18.24. Now I'm going to round it up. Basically, I'm going to help you in rounding of data. You are going to drop this 4. So when you will drop this 4 is less than 5, so it will have no effect on this next left digit, so it would become 18.2. But still I have three significant digits, so I'm going to drop this 2 as well. 2 is also less than 5, so this will not affect on 18, so 18 is my answer. This has two significant figures. Is this clear to you?
Yes, sir. Yes, sir.
Yes, very
Yes,
good.
sir.
So
Yes, sir.
that's perfect. That was basically the concept when significant figures were the role significant figures have in our values. In the same way, when we are going to write the data or when we are going to write the number in terms of power of 10, for example, in case of power of 10, in case of power of 10, what would be the rule? Let's say you are going to write 3 times 10 power 8 meter per second. Do you know what is that? Can anybody tell me? This is the value of a constant
Speed.
number. Yes, this is speed of light. Perfect. This is speed of light. So when I say that speed of light is 3.3 into 10 raised power 8 meter per second, so it means I'm going to mention this number in one significant figure. This is one number before multiple value, so it has one significant figure. But if I write 3.0 into 10 raised power 8 meter per second, so what would be number of significant figures I have? I have two significant figures. Is this clear to all?
Yes, sir.
Yes. So this would be basically helping in our measurements. No need to get worry about that. When I will be basically coming to that point where I need it, we will have a lot of practice about that. You can take a screenshot of this. I'm gonna switch to the next window of the book. Is it fine? Did you take the screenshot?
Yes, sir.
Yes, sir.
Okay. Sorry, I am
1 second, sir.
did not call all of you today one by one. Maybe I was in hurry to complete the lesson, but later on, inshallah, we will be able to do that. Now I have this window or these slides where we were talking about the measurements. Here it is the same, synchronized with your book. Here we have length measurements, right? Basically this all is now we are talking about the measurements of different physical quantities. So when I talk about the length measurements, we can measure the length with the help of different instruments. We will enlist all those instruments one by one, right? But we remember that what is the unit of length? Unit of length is meter, but we have different variables in our length measurements. For example, we have decimeter, centimeter, millimeter, right? Okay, so when we talk about this all, we have studied in prefixes this one, that actually 1 decimeter is equals to 10 power minus 1 meter, 1 centimeter is 10 power minus 2 meter, and 1 millimeter is 10 power minus 3 meter, and 1 micrometer is 10 power minus 6, and nano is 10 power minus 9. So these all are basically again a repetition of your prefixes. So I believe that you people will not get any trouble in this one. A multiple for large distance is a kilometer, right? When we are having a larger number for the length, for example, we can call it a kilometer. Is it? Right? A gigameter is 10 power 9 meter, a billion of meter, right? This is basically a billion meter. Billion, how many zeros are there in billion? 1000 million, isn't it? 10 power 9, na? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1 million, is it? Am I right? This is 1 million, and this is 1000 million. 1000 million is probably 1 billion, maybe. Yeah, it is 1 billion. You can calculate it by yourself, because mostly we reach to 3.0 into 10 raised power 8. So it is 300 million meter per second, right? It is speed of light. Anyhow, let's talk about very important precaution. We have different instruments to measure the length, right? Here I have mentioned those instruments in my notes, that length SI unit is meter. It is a scalar quantity. Here we have different instruments. First of all, we have measuring tape. What do we have? We have measuring tape to measure the length of instrument. How many of you have seen measuring tape?
I did, sir. Sir, me.
I have.
Yes, almost everybody have it at our homes, right? Just to, it is, very closely related with our clothing and stitching, all that stuff. So measuring tape is a flexible setup. Its length is, if I call it a meter roll, its length will be 1 meter. I mean 100 centimeter. It will be for meter roll, not meter rod, meter roll, or roll, you can say. This one. Then normally we have more lengthy measuring tapes, like it's, if I remember, it is mostly 150 centimeter, 160 centimeter, or 180 centimeter, something like that, right? Now you can check this one out at your homes, that how much do we have. I mean, normally standard we have 150 to 180 centimeters, right? Now the very, very important things, it has a marking similar to that of the rigid rule. I mean, rigid rule is basically your measuring scale, meter rod. It has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. In next slide, I will show you that. Right, the smallest marking that could be as small as 0.1 centimeter, or that could be larger as 0.05 centimeter, or even 1 centimeter. So its accuracy level is plus minus 0.1 centimeter. What does it mean? If you remember, if I zone this, oh, it is too much zone. This is a centimeter, right? This is a centimeter line. So if I say that the distance between this line and this line, it is basically 1 centimeter. So isn't it wrong? This one and this one. How many centimeters do we have in between these two lines?
1.
Or you can say in between these two lines. Yes?
1 centimeter.
It is basically 1/10 of a centimeter. Is it?
A millimeter, basically?
Yes, it is 1/10 of a centimeter, which is basically 0.1 centimeter. And when we call it, it is 1 millimeter. So it cannot give you accurate measurements less than 1 millimeter. So if I rearrange this, or if I have this length as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If this is 1 centimeter slot, then I can say that in between this, if I zoom this out, this gap is basically, this gap is how much? It is 1/10 of a centimeter. Am I right? So 1/10 of a centimeter means 0.1 centimeter. So as I told you that 10 millimeters are equal to 1 centimeter. Is it? How many millimeters do we have equals to 1 millimeter? Oh, sorry, 1 centimeter. 10 millimeters equals to 1 centimeter. So here it was 1 millimeter because it was 1/10 centimeter. So this can give you an accuracy of 0. It is 0.1 centimeter. This was incorrect. This was 0.1 centimeter, or it was 1 millimeter. Am I right? Is this clear to all?
Yes, sir.
Okay.
Yes.
Then we have a rod, meter rod, or meter rule or rod. It is basically usually called it rod. This is the picture what I wanted to share in the screen, but later on I realized that I have it. This is 1 centimeter space, and in that 1 centimeter space, this is the gap which can be the least accurately measuring value, because in between the gap you don't have any reading. So when you don't have any reading, you cannot measure it. Okay, so if it is made up of a rigid piece, so remember this thing, measuring tape is used to measure the things which are curved, and measuring rule or this rod is to measure the hard stuff. I mean, when you are going to measure the length of a block or a straight line thing, then we use it. But if we have to measure the length of the curved surfaces, then I will not be able to use this one. Then sometimes the question is asked to you. Now I will basically be able to show you some sort of questions, and then it would be I mean, we will be able to handle the answers as well. So again, it is 1 millimeter accurate. Then we have Vernier caliper. Although this is not included in your syllabus, but I wanted to show you this because Vernier caliper is one of the most important instrument for the length measurement. Just to show you this instrument and how to handle it, basically it is in your A levels, that is included in a syllabus, but only issue is three main parts: inside jaws, outside jaws, and a strip. Okay, this outside jaws are used to measure the outer diameter of an object. Okay, then inside jaws are used to measure inner diameter of an object. They are used to measure outer diameter or length of the object. Then this strip is used to measure depth of the object. So it has three main functions: outer depth, inner depth. Yeah, here it is. It is. Oh, very good, very good. I worked. It means I have shown you all the things over here. Well done. This well done was for me as well, right? So this is what, this is the diameter of any sphere. So this is called outer diameter because you are going to measure its outer boundaries, and this is called the inner diameter. For example, this is a test tube and you are going to measure its inner width or inner thickness, right? So these two jaws will give you the inner diameter over here. And if I want to measure the depth of this tube, how deeper that is, I will use its tail, right? It has two scales. This sliding scale is called your Vernier scale. Okay. And this fixed scale is called your Mann scale. Okay. So these are the instruments which are used to take reading with the help of two scales, not by single scale. That's why its accuracy is 10 times greater than your instrument, I mean your meter rod. So this can give you accuracy up to 1/100th of a centimeter, which is basically equals to 0.01 0.01 centimeter, 0.01 centimeter, or that can be 0.1 millimeter. Is it clear to you? So remember this thing, that most of the times we now this thing that its accuracy level is 0.01 centimeter. What was the accuracy level of your meter rod? 0.1 centimeter. It is 0.01 centimeter, right? Is this clear to all?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, it was just an introduction for you from this instrument. This is a bit detailed. You can go through that. A pair of external jaws, E to F, is measured to external diameter. A pair of internal jaws, C and D, they are used to measure the internal diameter or thickness of the wire or something like that. And a long rod G is to measure the depth. How to use this is just I have added in the notes. That is not, you will not be asked about that, right? But here jaws are first closed to find any error in it, which is called your zero error. It is called calibration basically. Then the jaws are open again and the object is fit firmly, and then the readings are taken. That's it. It is basically enough for you to know that how to use it. First we close these jaws, I mean these two jaws, without placing any object. This jaw is shifted over here. Maybe I have it in your book slides. Maybe I'm not 100% sure that he has shown this, but maybe it is no. He has not mentioned this instrument over there, but maybe in the book in detail there would be. So I have figured it out from different diagrams. Okay. Now there is another instrument which is called micrometer. Oh, beautiful instrument that is. Perfect. I like that diagram, man. This is very high resolution diagram I got from anywhere. This is another instrument. It has also two scales. One is barrel, or we can call it sleeve, right? Here it is written. Then it is thimble. These names are not to remember this thing, just to give you an information. Yes, Yusra?
Sir, will these diagrams come in paper?
No. Just when you will go to physics lab anywhere in your life, don't get horrified that what these things are. That's why I'm going to give you an introduction that these are some sort of instruments which are being used to measure the length. That's it. No more than that.
Okay, sir.
Is it? Yes. So don't get horrified about that. Now, basically, it measures the length up to 0 to 25 millimeter. Its accuracy is very high. Its accuracy is basically 0.01 millimeter, 1,000th of a meter. Sorry, centimeter. I mean, if I consider all of the things together, yeah, here it is written. Its accuracy is 0.01 millimeter. So again, I will go back to this. Just this object is coming closer to this. Close these jaws, then find anywhere that it is not uncalibrated. Then put the object inside what you want to measure. Again, open it up and take the reading. That will give you reading by two scales. That's why it is basically again in over A levels. So when we are going to take measurements from any of the object, either we are going to measure length, volume, or whatever, we have to avoid parallax error. Okay, what we have to avoid? Parallax error, right? Here it was basically explained in your slide of book that a person was taking reading from different positions. Check this one out. This was the edge of a rod or an object, and this is a scale placed along with that. If a person is going to read from this point, he will read this value 70, 75, 76, 77. He will note down that, okay, I have 7.7 reading or 77 centimeter over here. The person who will be reading from this, he will also be having a wrong observation from here. So these two positions are wrong. So the object or the scale should be perpendicular to the line of sight to avoid the parallax error. So this is the accurate value. What is that? This is the accurate value. So whenever you are going to measure the length, please avoid parallax error. Got it?
Yes, sir.
Yes. So
Yes, sir.
this was all about today's lesson. I hope my pace was bit faster, but not that much that could not be caught up. But my main target was to give you an introduction about significant figures, rounding of data, and measurement of length with different instruments. Is this all clear? Or you want to ask any question?
No, sir.
No, sir.
No,
Sure. Okay. So I have, I will send you the recording of this because I have recorded the lesson. Hopefully it would be saved with me, and as well as the slides where we have studied from different snapshots. Yes, last day I sent you all the screenshots are in terms of pictures at the group. Were they helpful for you? Because some students cannot take screenshot when I'm going to reach, so that will make them easy to note down the data. So is it easy to all of you?
Yes, sir.
Yes, sir.
Yes. Okay. So next topic, inshallah, we will be able to cover all that top chapter, measurement of area. You people are known to that to somehow. Then measurement of volume, right? For regular objects and for irregular objects, that is a very important topic because it will lead me in another chapter. And then we will talk about measurement of time, right? Then we will talk about mass, weight, and density because that is another chapter. This is next chapter, but I have added it up in measurements because this all is related with measurements, right? Volume measurements, then mass measurements, then weight measurements, right? And all that stuff. So hopefully with the passage of time, we are getting closer and closer to our exam stuff questions. Okay, so be in touch, inshallah, and don't get scared of physics. We will make it very easy, inshallah, together. I mean, I will not make it easy for you alone. You will help me out as well. Okay?
Sir,
Yes. Any question?
when our exam will be started?
We have a schedule for exam, and I hope that that would be displayed to you as well, right? We have some monthly assessments, but when you are going to appear in your final exam, it is your 2024, inshallah. Okay?
Sir.
Okay.
Any other question? Any other question from any of the students?
No, sir.
No, sir.
No, sir.
Oh, great. So I hope that we had very good weekend ahead because we have completed the classes of this week. Alhamdulillah. Hopefully this was really, really, amazing coordination with you people. Alhamdulillah, Alhamdulillah. I really enjoyed this. Hopefully you have enjoyed too. So probably we will be anywhere together. Okay, see you inshallah in my next session, because we will have some classes on Monday till Thursday, and then we will be able to finalize the things with till mass, weight, and density, inshallah. Okay, any question if you want to ask, I'm here.
No, sir.
No, sir.
No, sir.
Okay.
No, sir.
Okay,